How a pool heat pump works. A pool heat pump doesn't actually make heat like a gas or electric heater. Instead, it captures free heat energy from the surrounding air and transfers it into the pool water. Amazingly, it can still pull heat out of the air even when outdoor temperatures are near freezing. Here's how it works. A fan draws outside air across the evaporator coil, where the refrigerant absorbs heat and turns into a gas. The DC inverter-driven compressor then pressurizes this gas into a hot vapor. That hot vapor flows through the titanium condenser coil, where the heat is transferred into the pool water. The refrigerant cools, turns back into a liquid, and the cycle starts again. The inverter control is the secret. Instead of switching on and off, it continuously adjusts the compressor speed. This makes the system more efficient, quieter, and more durable. And thanks to a four-way reversing valve, the unit can both heat in cold weather and cool in hot weather, or run a defrost cycle when needed. Let's walk through how to size a pool heat pump so your system is efficient, cost-effective, and keeps the water comfortable all season. The first step is to gather your pool information. Measure the length, width, and average depth of the pool. Multiply those to get the volume in cubic feet, and then convert to gallons by multiplying by 7.48. If you already know your pool's gallon capacity, you can skip this step. Next, calculate the surface area by multiplying length by width. The surface is important because most heat loss occurs through evaporation at the water's surface. Now decide on your target water temperature and compare it with your typical design outdoor temperature during the swimming season. The difference between those two numbers is your delta T. For example, if you want the water at 82 degrees and the evening air is usually 60, your delta T is 22 degrees Fahrenheit. To estimate the heat load, apply a heat transfer coefficient, U. For an uncovered pool, use about 10 BTUs per hour, per square foot, per degree Fahrenheit. If you use a reliable thermal cover, you can reduce U to around 3. Multiply U by the surface area and by delta T. The result is the steady-state heat loss in BTUs per hour. Finally, convert that number to kilowatts or tons by dividing by 3,412 for kilowatts, or by 12,000 for tons of cooling equivalent. Add a 15 to 20% margin to account for wind, piping, and cycling losses. That's your recommended heat pump capacity. Here's the big takeaway. An uncovered pool may need 3 times more heating capacity than a covered one. Here's a worked example of pool heater sizing. We're looking at a pool in New York that's 30 feet long, 15 feet wide, and 6 feet deep on average. That gives us a surface area of about 450 square feet and a volume of around 2,700 cubic feet. Converted, that's just over 20,000 gallons of water. The desired water temperature is 82 degrees Fahrenheit. For sizing, we'll compare this against an outdoor ambient of 32 degrees, which creates a 50-degree temperature difference. Now, let's calculate the heat loss. For an uncovered pool, we use a heat transfer coefficient of 10 BTUs per hour per square foot per degree Fahrenheit. Multiplying U by surface area and temperature difference, the load comes out to 225,000 BTUs per hour. That equals about 66 kilowatts, or nearly 19 tons of cooling equivalent. When we add a 15% safety margin for wind, piping losses, and cycling, the requirement increases to about 76 kilowatts, or 21.5 tons. With a thermal cover, the effective heat transfer coefficient drops to 3. Running the same formula, the steady-state load falls to about 67,500 BTUs per hour. That's 20 kilowatts, or roughly 5.5 tons. After applying the margin, the covered pool only needs about 23 kilowatts, or 6.5 tons. The key takeaway is clear. With a cover, the heating requirement is reduced by almost 70%. That means smaller equipment, lower energy bills, and much better efficiency over the swimming season. So, when considering heater sizing, always factor in whether the pool will be covered or uncovered, because it can make the difference between needing a 70 kilowatt heater or a 20 kilowatt one. That's 20 kilowatts, or roughly 5.5 tons. After applying the margin, the covered pool only needs about 23 kilowatts, or 6.5 tons. The key takeaway is clear. With a cover, the heating requirement is reduced by almost 70%. That means smaller equipment, lower energy bills, and much better efficiency over the swimming season. So, when considering heater sizing, always factor in whether the pool will be covered or uncovered, because it can make the difference between needing a 70 kilowatt heater or a 20 kilowatt one.